So we have steps for evaluating the trigonometric functions at any angle. So to find the values of the trigonometric functions for any angle theta, we carry out the following steps. So finding the reference angle theta, and when theta has a line over it, it just means it's a reference angle. We don't say anything different for it, associated with the angle theta. So we have to find the reference angle first. We then determine the sine of the trigonometric function of theta. All students take calculus. And then we find the value from the terminal point. And we change it based on the needed sine. And then we have evaluated the angle. Alright, so we're going to use the reference angle to evaluate trigonometric functions. Our first one is sine of 240. And it's in degrees, so we know that 240 is going to fall after 180 and before 270. So it stops over here. We are closer to the left side of the x-axis, so we need to get our reference angle. 270 minus 180 gives us 60. And we are in quadrant 3. So we use our trick, and we see that sine is going to be negative in quadrant 3. So we are now looking for the negative sine of 60. Well, we know 60 degrees. The important degree markings were 30, 45, 60. We're up here. Use the left-hand trick. You get the point to be 1/2 root 3 over 2. We want the y value for sine, and we want it to be negative, so it goes to negative root 3 over 2. We're looking for the cotangent of 495 degrees. Subtract 360 from it, because we already did one full rotation. Cotangent of 135 degrees is now what we're looking for. So we know the cotangent is going to of 135. So I'm going to stop over here. So then the reference angle to complete to the nearest x-axis is 45 degrees. Cotangent, you're in quadrant 2. Quadrant 2, only sine and cosine are positive, so we want the negative value. So we want the negative sine over cosine, or cosine over sine because it's cotangent. It's the point root 2 over 2, root 2 over 2, gives us a negative root 2 over 2 divided by root 2 over 2. It's all going to cancel out and go to 1 in the middle, so you get -1 for your answer. You can also be given your starting value in radians. It's no different. You're still seeing where does this fall on the circle. So we have sine of 16 pi over 3. When you have thirds, you need 2 pi. So 2 times 3 is 6. 6 goes into 16 twice. So 16 minus 12 is 4. So we are really taking the sine of 4 pi over 3. So here's 0, here's pi, here's 3 pi over 2. So we are just over 1 full pi. And we stop here. This is your 4 pi over 3. Our reference angle, theta, is going to be this additional pi over 3 that we traveled past the x-axis. We're in quadrant 3, so that means it's going to be a negative sine of pi over 3. Pi over 3 has the reference point, or the terminal point, root 3 over 2, 1/2. Sine is the x value, so it goes to negative 1/2. No, I gave you the wrong reference, or wrong terminal point. Pi over 3 is up here. Sorry about that. It is the point 1/2 root 3 over 2. So it goes to a negative root 3 over 2. Then if you have the secant of negative pi over 4, going negative is going clockwise to right here. This is negative pi over 4. So we're only pi over 4 away. So our reference angle is pi over 4, which is the point root 2 over 2, root 2 over 2. We have secant, which is going to be positive in quadrant 4. Secant is 1 over the cosine. So 1 over the x value, root 2 over 2, goes to 2 over root 2, and you have to rationalize the denominator. And you get out root 2.